Well, welcome to section 3.4. This is about taking derivatives of geometric functions. It's a really short section. I'm going to cover just kind of the basic highlights of it. There's a box in the book that you need to take a look at that gives you a little more detail about some of the specifics, but this will get you the general idea of what's going on in this section. When we're done, you should be able to take derivatives of trig functions. All of the derivative rules that we already know how to do, that we picked up in the last couple of sections, will apply to the trig functions as well. And you just need to know how to do the things that you already know how to do. I think you'll see here as we go through this. One of the things that's really important, really got to make sure you have down, everything that we do from now on is going to be in radians. So if you see a trig function and you're evaluating something, it's in radians. It's got to be in radians. Let me emphasize that. It's got to be in radians. If you're not in radians, you're going to screw up. It's got to be in radians. So flip your computer screen around to make that turn up right side up. All right. Let's start with the sine curve. Basic sine curve looks like this. Period of the sine curve is 2 pi. So out here, let's see, this would be right there, 2 pi, which would be 1, 2, 3, 4, 5, 6.28-ish. So there's this normal sine curve. And what I want to do is take a look at what the derivative would look like. Well, as we've done in the other problems, we've always kind of taken a look at where the horizontal tangents would be, because, of course, the slope there is 0. So at every one of these points, you've got a horizontal tangent, which means the derivative of the sine would have a 0 at that point. So I'm going to put the zeros in on the graph. So 0 here and here. Everywhere there's a horizontal tangent, you're going to have a 0 for the function's derivative. Now, in between those points, notice here it's kind of positive slope in here. So I'm going to have positive values of some kind. And it doesn't look like it's going up all that steep, maybe a slope of 1 or so. Notice over here that from here to here, you've got negative slope. So after I cross here, I'm going to cross and be negative. And then it goes back to positive again, and so on and so on. The graph keeps flipping back and forth between positive slope and negative slope. So let me kind of fill in what it kind of looks like. So I've got the zeros here and positive values for y in between because I have positive slopes. And if I take a look just at that graph, so the question here is, what does that graph look like? Well, if you kind of think about what you're doing there, as it turns out, it's the derivative of the sine is the cosine. Now that's what this notation says, right? The derivative with respect to x is the variable, of the sine is the cosine. Know that. You've got to have that down. Let me go take a look at the cosine curve and see if we can figure out what its derivative is. I'm going to do the same logic. Look, I've got horizontal tangents at all of these points, right? And that means I'm going to have zeros on the function at those points. And then if I connect the dots thinking about, you know, positive slope versus negative slope, look, this is negative slope right here, so I'm going to have negative function values. Oh, I've got positive slope over here, so now I'm going to have positive function values. Well, connect all the dots looking at the positive slope and negative slopes of each of these points. What you're going to get is a graph that looks like this. And if you think about it for a little bit, that equation is the cosine curve, but it's upside down, so it's the negative cosine. So the derivative of the, I'm sorry, I said cosine. Back up. Need to change that to sine. There we go. So the derivative of the cosine is the opposite of the sine. Oops, one away. There we go. Keep up with it. It was you had the wrong pen out. Sorry. So in the book here, as I said, there's a box on page 152 that you need to take a look at. There's all of the derivatives for the trig functions there. Know these derivatives. They just come up. This is just kind of you got to have it down. So spend some time. Get to know those values. That is it. I told you it was kind of short and sweet. Hopefully it goes well for you.